Hand up if you can tell me anything at all that you know about fractions. Anything at all that you know about fractions, Chandelier? What can you tell me? One of them is a half? Okay. What are you going to tell me about a half? Sit up, thank you. What were we accidentally calling it yesterday quite often, Chandelier? Chandelier? One tooth. Why did we get confused and we were accidentally calling it one tooth, Rajiv?
Because the one in the middle there's this line, and then in the bottom there's this like two, and they get confused because there's two is on the bottom.
Okay, the two is the denominator. The two is the denominator. It is at the bottom. But why were we going at the end? Do you know? Nick? But it didn't make sense for the half, did it?
Yeah.
What are almost all the other fractions? What happens to them when you read them?
Kind of the same. Yeah.
What happens to them when you read all the other fractions? Turn around, Casey. Rajiv?
They're all the same, but the one
Okay. Looking at the ones that are behind me on the screen, put your hand up if you can read me one of them. Matua?
1/5.
1/5. What happens when you say 1/5? What do you say at the end?
You say
Fifth. That's right. What's another one, Kiana?
1/6.
1/6. That's right. What's another one, Leon?
1/100.
1/100th. That's right. Actually very good at them. What's another one that you can see up there, Jolyn? 1/15th. What do they all end with?
5th.
Okay. So why then do you think, Lucas? Okay, yes, we're talking about fractions. So what happens? What's the one with the 4 as a denominator? Do we say, can we say fourth?
Yeah.
Emily, put your hand up if you can tell me what the other name for the one with the 4 at the bottom is. We were doing it yesterday.
Half.
What's the other name for the one with the 4 as the denominator, Nick? 1/4. Okay, if I gave you a cake, who am I going to ask? Kiana. Would you rather have 1/2 the cake or 1/4 of the cake?
1/2.
Why would you want 1/2?
Because it's more.
It's more.
And I love cake.
And you love cake? Yes, me too. Okay, Desire, if I gave you a cake, would you rather have 1/8 of the cake or 1/15th of the cake?
1/8.
Why?
Because it's more than
Okay, cool. So you mean the number at the bottom? What does the denominator on a fraction, that's the number at the bottom, tell you? Why is that number there, Rajiv?
To tell you how many pieces there is.
Excellent. How many pieces there are. So again, if I have a cake and the cake is cut into 16ths, right? Would you rather have, put your hand down so you've heard the question, 2 16ths or 5 16ths? Which one of those is bigger? Chandelier?
2 16.
You think that 2 pieces is bigger than 5 pieces? Can you see the number at the bottom is the same? So the cake's been cut into 16 pieces. They're all the same size, aren't they, Taniora?
Yep.
So would you rather have 2 16ths or 5 16ths? Which one would be more? 2 pieces is more than 5 pieces. Is that what you're saying? Which one is bigger?
5.
5 what?
5, 6.
Because, okay, cool. So you imagine something cut into 16 bits. Okay, it's both the same denominator. Both of those fractions have the same number at the bottom.
So then it'll be up to the top ones.
Yep, so then you look at the top ones. If the denominator is the same, you look at the top number to tell you which one's bigger. So the bigger top number is the bigger piece. Okay, here's another one. If I have a cake and it's cut into 20ths, put your hand up and you can tell me which is bigger. So I've got one that is cut, I've got 3 20ths or I've got 15 20ths. Which one of those is bigger, Tefaya?
20th.
How do you know?
Because the bottom ones are the same, but the three's the smallest, so we'll go 15.
Cool. So how many pieces would you get if you had 15 20ths?
15.
15 of them. How many pieces would you get if you had 3 20ths? 3. So which one's bigger?
15.
Okay. Okay. Which would be bigger out of... Okay, I've got 2 cakes. The cakes are the same size. One of them is cut into 15ths. One of them is cut into 20ths. Okay? Which would be bigger? 3 15ths or 3 20ths? Matua?
3:15.
Would be bigger?
Yes.
Excellent. How do you know?
Because the 3 and the 3 is both the same.
But the denominators, the number at the bottom, is different, isn't it?
Yeah.
So which pieces are bigger, 15ths or 20ths?
15.
So if you had a cake cut into 15ths and you had 3 of them, they'd be bigger pieces, wouldn't they, than a same cake cut into 20ths? Awesome. So today I'm going to hold up, when we do Round the World, I'm going to hold up 2 fractions. And you've got to tell me which one is bigger. So who can remember the name that sounds a bit like Terminator that I've been using a lot today? Which number will you be looking
The smallest
Hands up. Thank you. What's the name that starts with D? Shh. Okay, and it's at the bottom of the fraction, Nick? Denominator. Okay, it sounds like Terminator. I always think of Terminator. Denominator. Okay, put your hand up and tell me what the denominator tells you in a fraction. Casey? Okay, what if in one fraction, just a fraction on its own like this one, what does the denominator tell you? Okay, yep, so what fraction has that shape been cut into? In this one. How many pieces would there be altogether if it was filled up? 5, you're right. Okay, so the denominator tells you how many bits. Okay, how many altogether? In a whole. Not in a hole, but in the whole cake. How many altogether?
5.
Okay, so the number at the top's got another name that sounds a bit like Terminator 2. It ends with nator. It's not Terminator. Oh, see, it hasn't got an N in it. Actually, Mrs. Bridewell, what are you doing? It's right. Okay, so the number at the top is called the numerator. And the numerator tells you how many bits you get. Okay, so if you had 2/5 of a cake, how many pieces would you get?
1.
If you had 2/5 of a cake, how many pieces would you get? 2. If you had 4/5 of a cake, how many pieces would you get? Awesome. Okay.